Students, can you people hear me clearly? Yes? Hello?
There is a
Can
bit
you
of a noise.
I'll switch off the fan? Okay, fine now.
So there's an option in Teams to add noise suppression, so the fan noise will be
Where
less.
is it? Where?
So in settings, when you go to is there device settings there on the three buttons itself? There is that device setting.
Device
So
setting is
that
there.
right, the noise suppression you can set it to high.
Where?
Down. There
Okay.
auto default, yeah, that one you can set to high.
Now let me switch on. Is it fine now?
Yeah, it's a bit better from before, but it's still there, sir. So
Okay, fine. I have switched it off, and I hope now it's better, right?
yes, sir. Now it's better.
Okay, students. Okay, so kindly please concentrate. I think so. I have to increase my pace little bit. Okay, so there are so many things remaining. If I go at this pace, we might lag, or else we might go for an extra class also. Okay, so it's better. I will try to maintain the pace. Okay, if possible, we'll have a class, extra class on Wednesday between 11:40 to 11:40 to whatever the time is. It's just for half an hour, 40 minutes. That's all. Okay, so I request you to please, I will concentrate and follow me up. Okay, but I will try to keep up my pace. Okay, so that you people can understand the most important thing. Okay, so we were seeing about MLP. Okay, and we were talking about feed forward. Okay, now what is back propagation algorithm? Back propagation algorithm is a supervised learning algorithm for training neural networks. So now what will happen is, students, okay, so you will calculate the feed forward, right? So I1 into W1. Okay, so then I2 into W2, right? You will do a summation. Then you will do an activation. The same way happens over here. Okay, so you will do a summation and you will do an activation. Then the output of this is multiplied with this, the output of this is multiplied with this. Then you will do a summation, you will do an activation. Activation function is given by sigmoid function over here, 1 by 1 plus e power minus 6. So whatever the value you get it in summation, you will plug in the values, you will get the activation function output. Okay, now once the final output has come predicted, yes, that is the predicted value, right? So say for example 0.04, you are getting the predicted output. You will already have a particular value over here, which is the actual output, say for example, okay, 222 or something like this is there. Okay, here you are getting 0. Say for example 84, whatever it might be, and 222. So this is my predicted output, which I have got through all these stuff. This is my given output, which I am supposed to get. Then I am going to compare. I'm going to minus. And definitely in this, there is an error. When there is an error, I need to go. It means that what the weights which I have set initially is wrong. So what I have to do, I have to update my weights, like how I did it in Adeline, right? But here the concept is different. The methodology is different. That is for single perceptron. We update it. But here it's a multiple perceptron. So what do? We back propagate. We back propagate. We back propagate by updating the weights using a methodology, using a formula. So initial weights were, say for example 1.41, means I will back propagate. I will update this. So what is it? W1, 2, 3, 4, 5, 6, right? So let me say W1, W2, W3, W4, W5, W6. So I will update W5. Then I will update W6. Then I will update W1. Then I will update W2. Then I will update W3. Then I will update W4. Then after updating the weights, then again I will do the feed forward. 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 Then again I will calculate the output, and I will check whether this output and this actual output difference has reduced or not. Okay, the difference between these two, say for example, if it is 0.6, this will come to 0.5, 9, 9, 9. So there will be a small reduction in the weight. So if I run this for 10,000 times, I might get for 0. Say for example, I might get for 0.02 times if I keep updating the weights. So that is the main logic behind back propagation. First, you will do the forward pass, you will calculate the total error, then you will go in a backward direction, and then you will update the weights such that in the second time, in the second iteration, in the second epoch, when the feed forward is done and when you get the output, the difference between the first iteration and the second iteration is reduced. Okay, just like how we did in Adeline, right? Adeline, in the first iteration and the second iteration, the error got reduced, right? But that is for the single perceptron. But here we are going for multiple perceptron updation of the weights. Is it clear, students, what I am trying to say? Hello, is it clear? Is it clear?
Yes, sir.
Hello?
Yes, sir.
Okay. Okay. So I am going here. Okay. I am going here. This is my predicted. This is my actual. This is my actual. What I am supposed to get. Okay, so but when I'm doing all these math, what I am doing all these math, okay, 2 into 0.11 plus 3 into 0.12 plus 0.158, then 2 into 0.12 and 3, then I will do the summation activation function, then summation, then activation function, then summation output, then summation output, then again summation activation function. So the activation function, when I'm getting this prediction, the prediction minus actual. No, it is actual minus prediction. It is actual, whatever the actual value minus of the predictor. I'll show you with the help of a problem. Okay. So when you're reading the weight, this is the same methodology of the gradient descent is used. Okay. So gradient descent is basically we go for reducing the weights. We go for reducing the weights. Okay. I mean, we go for reducing the errors, not the weights, but we go for reducing the errors in case we want to minimize the error function. Okay, fine. So same thing, calculate the error. Error is minimum. Fine, model is ready. If no, update the parameters. Okay. Now this is the problem. This is the problem. So we have input layer. We have one hidden layer, and we have output layer with each two neurons. Two inputs in the input layer, two neurons. In the hidden layer, two neurons, and there are two outputs. And in the output, we have two neurons. So each layer is having two neurons with the bias. With the bias. With the bias. Okay? With the bias. And see the weights of the bias will also be given. The weights of the bias will also be given. The weights of the bias will also be given. Okay? So this is the problem. So have a look at it for another 5 seconds closely. Okay? Input layer, hidden layer, and an output layer. Okay, input layer two neurons, hidden layer two neurons, and the output layer two neurons with the bias. And you see, with the bias, with the bias, with the bias. Okay, added to the each layer. Okay, fine. So why we go for biases? So for example, if we don't go for the bias, if the w1 value, w of x1 value is 1, what will happen? I have told you multiple times. Then the line will pass through the origin. But if we add a bias, then the line will not pass through the origin. It will pass outside the origin. Okay, so because if everything is 0, then it definitely is going to pass through the origin. So that is why we are adding the bias. Okay, fine. So the input values is zero point 0.5. Input x I1, input I2, 0.10. Okay, the weights are given. The weights are given. W1 weight 0.15, W2 weight 0.20, W3 0.5, W4 0.30. Okay, W4.0. Then this one bias. Okay, H2. Okay, then what is that thing? Then we have 0.5. over here. Okay, then 0.50, 0.50, 0.40. Okay, then the output expected 0.1. Okay, so here bias 0.30. Okay, so bias is 0.31. So 0.31 is going to both. Okay, and the 0.60 is going to both. Okay, so 0.60 over here and 0.60 is going to both. Okay, and the output values. Is this diagram very clear, students? Is this diagram very clear? Is this diagram very clear, everyone? Just a second.
Yes.
Just a second. Okay. Hello. Yes, is it clear? Okay, fine. Now the first step, step number 1, calculating the error, a total error. To do that, what will the first thing do? We will calculate the net weight at H1. Okay, so I told you, right? I told you, right? So first we will be doing summing, then the activation. Summing, then the activation. Summing, activation. Summing, activation. This summation I will be representing as net. Okay, the activation I will be representing as out. As out. Okay, fine. Just rub this off. So first one we'll be calculating the summation, then the activation at every hidden layer, at every layer. Okay, leaving the input. Okay, because here input and the output we are going to calculate. Okay, net. So I1 into W1 plus I2 into W2. Yes, into the bias. Can you see the bias is also coming? The bias is also coming. So I1 W1. Okay, I2 W2 bias into 1. Bias into 1. So what is the net? So what is the value of W1? 0.15. I1 0.05. I2 okay 0.10. Okay, and the weight zero point 0.2. You see, and the weight 0.2. Okay, 1 second. Point 0.10. Okay, where is W2? W2 0.20. Okay, 0.20. Okay, then 1 into 0.35. 1 into 0.35. When I do the math, I get this. Okay, so summation is over. Summation is over for H1. Then what's next? Activation. Activation. So activation means what is the formula? Okay, 1 divided by 1 plus e power of minus of net of H. If you're using X, you give minus X. If you're using your name, give it as minus whatever the name is. Okay, so here I'm using net of H1. So for simplicity. Okay, net of H1. So 1 by 1 plus net of H1. When I do the math, I get this. The same I will do it for H2 also. That is I1 0.5. Okay, 0.5 into W3 0.25 and I2 0.10 into W4. Then I do the summation. Then I do the activation. Is this step clear? Then I get out of H2. Out of H2. Okay, net of H2 is not represented. So when I put the net of H2 value, I get out of H2. Is this clear till here, everybody? Hello? Is this clear to everybody? So this is the out of H2. Is it clear, students, everyone? Hello?
Yes, sir.
Yes, sir.
Okay. Okay. So I have got net of H1. I have got net of H2. Okay, which is not represented. Then out of H1 and out of H2 I have got. Okay. Then what? So then the output of this. Then the output of this, right? Summation, right? Summation. What we have got, the output of this is 0.59. Okay, the output of this is 0.59. Can you see a very small, minute difference? So this is 0.59 into so much, and this is also 0.59. So what I will do? So 0.59 into 0.40. Okay. Then 0.59, 0.5. Can you see? 0.59 into 0.40 into 0.40. Then W6. That is 0.59 into 0.45 into the bias. 1 into 0.6. 1 into 0.6. I get this. I get this. Okay. So then I squash. So this the summation is over for here. Then I squash. That is squeeze. Anything between sigmoid function, anything between, it will give you the value 0 to 1. Okay, activation function. So then I put this value over here. Then I put this value over here. Okay, then I get this value. Then I get this value. Then the same process is carried out for this. Then I do this, which is 0.59 into point W7, then point W8 into, that is 0.59 into 0.55, then into B2 into zero point 0.6. B2 into zero point 0.6. So I will get out of O2. I'll get out of O2. Can you see out of O2? So first I'll get net of O2. I'll get net of O2. Okay, net of O2 I'll get. Then when I squash, I'll get out of O2. The same process. The same process. The same process. Only the weights will differ. Is it clear till now? Is it clear till now? Hello, is it clear till now? Everybody, please quickly reply.
Yes, sir.
Yes, sir.
Yeah, yes, sir.
Okay. Okay. So now I'm proceeding forward. Now see here, I have got two values, right? At this layer, okay, which is already there, 0.1 and 0.99, which is already there. Okay. Now what I have got? So 0.75 and 0.77. So target minus output. The target is what? 0.1. The target is what? 0.1. So summation of the total error. I'm calculating the total error now. Okay. So we know that. Okay. This is 0. Where is it? Okay. So we know that we have got 7.5 over here. We have got 7.5 over here. Okay. 7.7. 7 over. So, but what are we supposed to get? 0.1. What are we supposed to get? 0.99. So there is an error existing. Yes or no, students? There is an error existing. So this is till here it is feed forward. Feed forward. Okay, the data was moving only in one direction, feed forward, forward pass. So till here, all these steps were feed forward. All these steps were feed forward. All these steps were feed forward, and then we have calculated value there. Okay, now there is an error existing. Now we need to move back and update the weights of W5. Okay, W6, W7, W8, W5, W6, W7, W8. Then W1, W2, W3, W4. Okay, so first I will update these weights. W5, 6, 7, 8. Then I will update these weights. Okay, now, so we have got this. So we have got this out of O1 and out of O2. In the meanwhile, we have got net of O1, net of O2. I have not represented. We have got net of H1, net of H2. Okay, out of O1 and out of H of 1, out of H of 2. Can you see? Okay, so we have got four things over here. We have got four things. Net of H1, out of H1. Net of H2, out of H2. The same thing, net of O1, out of O1. Net of O2, out of O2. Okay, now, so out of O2, fine. Now, having said that, now we have to calculate the total error. What is the total error in the network? So the formula is 1 by half, okay, into the summation of target of out of O1 into out of O2 minus target. The same way, okay, the same way, half of, you will calculate target of O2 minus of out of O2 the whole square. So now, when I do, what will happen? Half. What is the target? What is the target? 0.01. What have we achieved? 0.75136507. The whole square. When I do the math, I get this. The same way, I will be doing it for here 1 by 2 into 0.99, 0.99 minus what I have I get 0.7729, whatever it is, 0.7729 the whole square. Okay, when I do the math, I get this. Now the total error is E total. E total is EO1 plus EO2. Can you see the total error is whatever it got 0.274 plus 0.236. Is 0. This is the total error of the network. So first we calculated the individual error, then using this formula calculating the total error. So this is the individual error. Okay, this is the when you subtract this, right? This is the individual error. This is the individual error. This is the total error. This is the predicted value of the of O1 what we have got, and this is the predicted value of O2 what we have got. Is it clear till here? Is it clear to your till here, students? Hello? Is it clear till here? Okay. Now, having said that, now we have calculated, and definitely there is an error. Now we have to reduce this error. Now we have to reduce this error. How do we do it? How do we do it? When this error is reduced, then the difference between these two errors is reduced, automatically this error will reduce. That's the logic, that's the common sense. So now I will be having to go to back propagation. Then I have to update using a formula W5. Then I will update W6. Then I will update W7. Then I will update W8. First I will update this layer. Then after updating 5, 6, 7, 8, okay, then I will update 1, 2, 3, 4. Okay, now I'll back propagate. Now to back propagate and update, I can't do it. I do it with the help of derivatives. Very simple, students. Kindly follow me. It's very simple. Okay, update the weights using gradient descent so that they can cause the actual output to be closer than the target output, thereby minimizing the error. Okay, fine. So first I am going to update the weight of W5. Okay, the formula to update the weight of W5 is W5 new equal to W5 old minus the learning rate of dou E total, dou E total with respect to dou W5. That's all, students. Okay, so if I want to update W6, W6 new equal to W6 old minus of learning rate. That is, you can call it as an alpha or a learning rate in dou E total with respect to W6. Okay, the W7, if I want to add dou 7 new equal to dou 7 old minus of learning rate into dou E total by dou 7. Okay, the formula to update the weight for W8 is W8 new equal to W8 old minus of learning rate into dou 8 total, dou E total by dou 8. So just replace 5, 6, 7, 8. You will get the formula. This is the same way 1, 2, 3, 4, 5 also. So this is the common formula. So the generalized formula is I can call it as Wi new equal to Wi old minus of alpha equal to dou E total by dou Wi. So I will be 1, 2, 3, 4, 5, 6, 7, 8. Is it clear? Is it clear? Is it clear?
Yes, sir.
Hello, is it clear? Okay. So we know that already we know the weights of W5. Okay, alpha or the learning rate will already will be given. Now what we need to calculate? What do we need to calculate, students? What do we need to calculate? We need to calculate only this dou E total by dou W5. So we are updating the weights of W5. We need to calculate only this. How do we calculate? So how do we need to calculate? Where is W5? Where is W5? W5 is here. Okay, how am I going to reach W5 over here? Please understand, this is the summation. This is the activation. These are the layers. To reach W5, I can't reach W5 directly. There are layers in between. There are layers in between. Okay, and where am I? Under dou E total. With respect to, I have to reach 5. Okay, I am over here. So I need to, I hope you people have very good in the partial differential equations. You are genius in your 10th, 11th, 12th. Okay, math 1, math 2, math 3, whatever may be the math you have done already. Okay, so you should know partial differentiation. Okay, so but still I will just explaining you the upri upri concept. Okay, so now I want to update do w5. Okay, I want to update 5. Okay, then I will have to apply with respect to 6 7 8 the same thing. Okay, I will tell you for one, at each layer you need to calculate the same methodology, okay, with the help of 6 7 and 8. Okay, fine. So now students, please understand, the summation is means net. This is the aggregation, which is I'm representing by net value. Okay, and this one is the activation function. Okay, which I'm representing by out value. Okay, so first we do the summation, then we do the activation. First we do the summation, then we do the activation. Okay, but I am in do e total, so I have to reach 5. So how do I do it? So first I have to reach this part, right? First I have to reach this part, OE1. This is EO1. EO1. Okay, from that, okay, I have to reach out. That is the activation. Then I have to reach the net. Then I have to reach the W5. So will I do? How will I take the partial differential equation? So dou E total with respect to out. Then from out, I will reach to net. And from net, I need to read W5. So dou E total with respect to out. From out, I will reach net. And from net, I will reach W5. I will reach W5. Okay, I will reach W5. You should understand what is happening in out activation, what is happening in net summation. Okay, then I will be reaching calculating the updating the weights of W5. Okay, fine. So this is the overall formula. This is the overall formula to update W5. So now take this do E total. Now with respect to do out one. Okay, I am talking. I am in do E total. I am in do E total with respect to do out one. So what is the total? This is the total value, right? This is the total value we have calculated. This is the total value we have calculated. So total, we have to reach only, I have to take only this. Yes or no, students? I have to take only this. So I am in total. From total, I have to go from here, first one. Okay. Then from here, I will go to out to net and net to W5. So out. This is the total. So first I will be doing and I will be segregating. Okay. I will be segregating part by parts, layer by layer. Okay. So I'll just switch on my video. So I will be segregating part by parts, layer by layer. Okay. So now what am I going to do? What am I going to do? I will be cutting it part by parts. Okay, like something like dividing, conquer, divide, conquer, divide, conquer, divide, conquer, divide, conquer. Something like that I will be doing. So now E total by E1. So but my aim is to get E1 out. Okay, fine. How do I do it? So this is the overall formula. So when I keep this as constant and when I differentiate with respect to this, I get, okay, you know, right? How do I get this? Okay, I will not get inside all these terminologies. I hope you should be knowing and you know already. Okay, so minus target of O1 by out of O1. I get this part. I get this part. Okay, so minus target of O1, we know what is the value. Target of O1 is 0.01. It is already given and we have calculated what is out of O1. So when I do this, I get this. Okay, so this part is over. Now I am getting inside this part. I have got to this part now. I have got to this part. Okay, out of total, I was in total. From total, I came to, because total had EO1 and EO2. So now I have got to EO1. I have got to EO1 after partial differentiation. From EO1, I have two things, right? What are the two things I have? What are the two things I have? Summation and activation. So first I will enter into activation. Then I will enter into summation. So this is out. So do out one with respect to net. Okay, now. So what is out? What is out? So that is activation function. So this is activation function formula. So when I do a partial differentiation of this one, I get in the form of this. I get in the form of this, right? So e power x, e power minus, you do all these stuff. So but the formula is this. So when I apply the same methodology in this one for all the partial differentiation with respect to activation function, the constant formula is out of O1 minus of out of O1. The same thing out of O2, if I do it with respect to out of O2 minus of out of O2 will come. Okay. So out of O1 value we know. It's already we have calculated. Minus of out of O1. So this part is also over. This part is also over. The formula is given. Now I have entered here. Now I have to enter here net. Net. So net with respect to what? Net. What is the net we have calculated? What is the net we have calculated? Okay, can you see? Means 5 is also there, 6 is also there. That is H1 is also coming, H2 is also coming. H1 into W5 plus H2 into W6 will gives you net. But we need not take this. We are not bothered about this because we are updating only W5. And when we update W6, we are not bothered about W5. We are updating W6. Okay. So the same way. So W5 into out of H1 into W6 into out of H1. So this is constant. This is constant. We are not bothered about this. Now with the respect to which we partial differentiation, we get this one. We get this one, which is out of H1. Out of H1. That's all. Which is out of H1. So what is out of H1? We have already calculated. Now we have calculated this total EO1. Then we have also calculated the activation function. Then we have calculated the net value with respect to W5. Then when you multiply, I get the new updated weight of W5. This is the new updated weight of W5. Okay, sorry, this is the dou E total by W5. This is not the new updated weight. I'm very sorry about it. So this is the updated weight of E total by W5. Now what I will do, what is the formula? W5 minus of learning rate, okay, into DO total by W5. So W5 old we know. Learning rate is given for this question is 0.5. Okay, just plug in the values and then E total by W5 is 0. So then when you do the math, I get this. The same concept, I'll be doing it for W6, W7 and W8. I'll be doing for W6, W7 and W8. So I will be updating the weights of 5, 6, 7 and 8. Now remember, very important point students, very important point. Okay, now I have got the updated weights. I have got the updated weights. These updated weights will be used only for feed forward. Feed forward. That is for second iteration only. For the first iteration, when you are going back and in case where you are supposed to plug in the values of W5, you will not be using the latest updated weight. You will not be using the latest updated weight. You will be using the previous updated weight of W5 only. Old weights of W5 only. That is, if I am using, okay, if say for example, when I'm calculating for W1, if W5 weight is required, I will be using this weight only, zero point 0.4. I will not be using this weight, the latest weight. This weight will be used only for the next iteration. Is it clear, students, what I'm trying to say? Is everybody able to understand till now whatever I have taught you? Hello, quickly please answer. Hello, quickly please
Yes.
answer. Everybody, quickly raise your hands, quickly. Within 5 seconds, I want everybody to raise your hands if you have understood. If you have understood. If you have understood. Please don't waste time, please. If you have understood, raise your hands. It means that I have only 43 have understood till now. Okay, students. So having calculated W5, W6, okay, we have calculated till here, right? So we have updated W5, W6, W7. Now we will go through the hidden layers. Okay, now students, now I want to update. Please understand. Let me take a bigger picture here. I think so. This is nice to explain. Okay, now I want to update W1. Okay, to update W1, I can't directly get inside this, right? So I am over here again to begin from E total. From E total, okay, now see there are two parts. I have to come here. Then I have to enter into the activation function. Okay. Then I have to come to the summation function. Then only I can update W1. Then only I can update W1. Okay. So now what is the formula to update the weight of W1? W1 new equal to the same formula, equal to W1 old minus of learning rate into dou E total with respect to W1, with respect to W1, with respect to W1. Is it fine? Now let's get inside it. Now let's get inside it. 1 second, I'll just stop presenting and represent because that symbol is not going. Okay. Okay. So now students, now as I told you, so first I need to get into dou E total. So what is the formula? I have just calculated, right? So W1 new, this is the formula, right? Equal to W1 old minus of this one into dou E total by dou W1. So now I have to get this because other things I know. W1 old, I know this, I know. So this only I have to calculate. So dou E total with respect to W1. This is what I'm calculating here. Okay. Now having said that, how do I get to W1? So first I will get from E total to over here. From this is the activation function. From here I will get to net summation function. From net I will get to W1. So dou E total, from total I will get to out of H1. From out of H1 I will get to net of H1. From net of H1 I will be partial differentiation with respect to W1. It is layer by layer, segregating it, dividing it, segregating it, dividing it, and entering it layer by layer. So I hope you people know partial differentiation. Okay, now I am teaching that also. Okay, now how do I calculate dou E total by dou H1 out? Dou E total by dou H1 out. So dou E total by dou H1 out, can you see? Now there are two parameters playing a very important role. This out is dependent on this also and this also. This out is dependent on this also and this also. Okay, is that students? So I'll just write it down. So first I have to go from dou E total, dou E total, from dou E total to out, from out to net, and from net, okay, from net, okay, I will be going into what? W1. I'll be going into W1. Okay, so this is the formula. This is the thing. What I have. This is the whole formula stuff I have written here. So from E total to out, out to net, and net to W1. Okay, fine. Now I am going from E total. Okay, so from E total, if you see E total, E total, this out of H1 is dependent on two things: EO1 and EO2. EO1 and EO2 and EO2. Okay, so I'll be a little bit quick now. Okay, so can you see E total is dependent on EO1 and EO2. EO1 and EO2. Okay, now EO out of H1. EO out of H1, first I will calculate. Then EO out of H2, then we need to calculate. Then when we do it, I get E total of H1. Okay, so EO total of, can you see, out of H1. So this, how it is dependent? Out of H1 is dependent. How it is dependent? So EO1 is dependent on net, right? Net is dependent on out. Is it yes or no, students? EO1 is dependent on net. Net is dependent on out. Can you see? EO out O1 is dependent on net. Net is dependent on out. It's just to make you understand I'm writing. Okay, net is dependent on out. Okay. Now how do I partial differentiate this one? So EO out of net is dependent on what? Directly I can't enter into net, right? So net EO1 is dependent on out. EO1 is dependent on out. Out is dependent on net. That is what I have written. I'm further segregating it. Okay, and then when I do net of O1 with respect to H1, what will I get? Net of O1 with respect to H1. Where is net of O1 with respect to H1? Net of O1. Where is net of O1? Let me just see net of O1. Net of O1 with respect to H1. What will I get? This will get cancelled, right? Yes. With respect to H, net of O1 with respect to W5. Where is it? Net of O1 with respect to out of H1. Sorry, net of O1 with respect to out of H1. When I do this differentiation, what will I get? I get W5. I get W5. So that is what I have written here. Okay, I get W5. So now we know this value is W5 and we know the weight of W5 into, so we know out of H1. Okay, so what is out of H1? So when we do, 1 second. Yes. So EO1 of net of H1. So EO1 of net of H1 is what? Out of H1. So we know that, right? We have already calculated in the same way. So EO1 is the out of H1. This is the value we'll get. And this is the value of an out of H1 is we'll get this one, I think so, right? 1.86. See which value it gets. Out of O1 into net of O1. Out of O1 into net of O1. Out of O1 into net of, yes, this one. So when you multiply these two, you multiply this two out of O1 into net of O1. Okay. Multiply these two, you get this, and W58, you get this one. Okay. So you get out of H1. You get out of H1. Okay. Now, so the same thing you will be doing it for this is out of H1. The same thing you will be doing it for EO2 and out of H1 for EO2 with respect to H1. Because this is dependent on two things. This you have done. This you have done. First you have got into net to out. Okay. And then you have calculated it. Okay, here you have to reach, right? So the same thing how you will do this one, the same thing you will go for EO2 by OH1, then EO2 by net of O1. Okay, then EO by net of O1 by out of H1. Same thing you will do. Okay, then you will partial differentiate with this one, and then you will partial differentiate with this one. You'll get W6. Okay, you do it, and sure. So now having done that, so we have calculated this. Out of H1 into net of H1 means what? This is the activation function formula. Activation function formula we have already calculated. Out of O1, according you do it. If it's out of O1 or out of H2, according to the W1 or W2 or W3 or W, we have already calculated it. Okay. So wherever in whichever hidden layer we are, we will do accordingly. So in whichever hidden layer that this will change. So in this case, it is out of H1. So you will do it. We have already calculated. Net of H1. What is net of H1? This one. So with respect to H1, I calculated. This is the one which we are getting. Okay. Net of H1 into WF. Net of H1 into WF1, which is I1. Okay. If I calculate this one, we'll get I1. So what is I1? So when I multiply this value, and this value, I get the E total by W1. Substitute the value in this formula. I get W1. The same thing you can do it for W2, W3 and W4. Okay, W3 and W4. You get the updated weights also. Now you take the updated weights and forward, do a feed forward direction. The first iteration we got it as 0.29, right? This is the error, right? We got it as, what is the total? 0.29. So now we have the updated weights W1, W2, W3, W4, W5, W6, W7. You do the feed forward, okay, with the updated weights, all the updated weights. All the weights will be replaced with the updated weights. When you do it, then the total error will be what? Can you see the total error which is being updated? It's 0.29. Can you see there is a very small difference, but it has reduced. So, but if you plug in, if you run this for 10,000 times, then the error will be something like this. This is all about backward propagation. Is it clear to everybody? Hello? Is it clear to everyone?